Hello, AP Chemistry students. This is Mrs. Altman. We are on video number 41, Electrochemistry, Part 1. Here are our objectives for today's video. Pause here. So realizing that this is not going to be on your AP exam, we're not going to be focusing our review on this, but the really great thing about this chapter is that it's going to help us review redox chemistry, which I know is a weak point for many of the students here, because it's a difficult topic, not because it's something that you're like bad at, just a hard topic. So just a little review of it. You have to remember your oxidation states. So if you haven't done so already, make sure that you've reviewed them. Oxidation involves the loss of electrons. Reduction involves the gain. And how this applies to electrochemistry is that if we separate the oxidation and the reduction reactions, we can induce a current in a wire. This is how batteries fundamentally work, and that's what we're going to be talking about in this chapter. Pause here. All right, I'll work through this with you just because I know this is a little bit, it's been a while since we've done this. All right, so we're going to need to start by writing our oxidation and our reduction half reactions. First thing I see is that aluminum is oxidized because it goes from having an oxidation state of 0 to having an oxidation state of +3. Right, so you're probably wondering why I didn't include the oxidation or the subscript for aluminum on the right. And the reason why I didn't include that was because on the right, Al2O3, that is an ionic compound, so it's not really bonded. So I don't include subscripts that come from ionic compounds. For the reduction, I do have to include this subscript of 2 on my right before I actually start balancing it. And I have to have the same number on my, I have to include the 2 on the left, and therefore I have to put the coefficient on the right before I balance my electrons. I have 2 oxygens, each going from an oxidation state of 0 to -2, so +4 E minus. And now to balance my equation, I need to make sure that my electrons are equal. And so what I am going to do is I multiply my first reaction by 4 and my second reaction by 3. So my overall final answer, I put this 3 here and a 4 here. That part's pretty easy for most of you. But then I need to have 3 times 2, 6 oxygens, 4 times 1, 4 aluminums. So I actually put a 2 in front of here such that I am able to have my equation be balanced. Pause here. Okay, so sometimes you're going to end up in a position where you need to balance something and it looks like it's impossible, and it's actually not impossible. There's a method to it. So we have to assume that it's in an acidic solution. And the reason why that's a fair assumption is because acidic solutions are really, really strong oxidizing agents oftentimes. So they tend to cause oxidation reduction reactions to have happen. So I've listed the sort of rules here. Oh, there should not be an equal sign there. I am sorry. I've listed the rules here, and I'm actually going to break this into 2 videos and do an example in the next video, but I want you to have these in your notes. So we're going to write your separate oxidation and reduction half reactions just like you normally would, but you're going to hold off on putting the electrons in there. First, you're going to balance all elements that are there. Besides hydrogen and oxygen, you leave those alone. Then you're going to balance oxygen by adding water wherever you need to. I'll talk about that more next video. Balance hydrogen, balance charge, and then go from there. I'm going to have to stop this video and make a second one, but we're going to do an example in the next part of this video.